Git can have a high learning curve, but having worked with Git for a number of years, I've only really used a handful of Git's features. In my experience, spending time learning everything was really unnecessary when starting out as a junior. And so I want to run through only the more commonly used commands. Any features not covered in this video, you'll learn on the job or pragmatically when you actually need to use it. I'm going to make some assumptions. The first is that you're a junior developer and trying to learn Git. Secondly, you're comfortable with using the command line, whether it's on Windows, Mac, or Linux. I highly recommend that you learn Git using the command line over any Git-based application, at least when starting out. So in this video, I'll start with an introduction of what Git is, and then run through, in my opinion, the minimum you need to know as a beginner. Git is a version control system for tracking changes in any sets of files, usually used for coordination work among programmers collaboratively developing source code during software development. In other version control systems, each developer gets a working copy that points back to a single central repository. Git, however, is a distributed version control system. Instead of a working copy, each developer gets their own local repository complete with a fully tracked history. This means that it's easy for developers to collaborate and even prevents any single developer from blocking the work from another. The first clarification to mention is that Git tracks code with commits. Think of commits as the versions of the code base, and each commit is its own version. When a developer is working on a Git repository, they are usually working with the last or latest commit, as that is the most up-to-date version of the code base. In fact, a developer can theoretically choose any existing commit on a Git repository they wanted to work from. So if it helps, Git commits are basically unique versions of the code base, hence version control. And to demonstrate, I have here an empty text file in a folder or directory. I can start by initializing Git for this folder, which in Git terms is now a Git repository. If I run git status, it will show some information. The first is what branch I'm on, which I'll get to next, and at this moment, untracked files. Untracked files are files which Git hasn't tracked and therefore cannot determine what has or hasn't changed. If I stage this file by using git add and run git status, I'll now see that the file is tracked. And if I make an edit to this file, save it, and run git status, Git is now able to tell what has changed since the last stage. With Git, I'll be able to see the difference with git diff. Let's say I'm happy with this change, and I'll commit it with a message. I'll need to stage it first. You can see with git status that these are the changes to be committed. You can then commit with the git commit command. And I'll leave it with a message. First commit. Think of any unstaged code as a draft, meaning that it is currently a work in progress. Then when it's time to review that draft or change, you use what's known as staging as a way to state you're content with that particular change when reviewing or proofreading your code. Then once you're happy with everything that has been staged, you can commit that change. So if I run git status, we can see that we're on branch master and there's nothing to commit. If I were to then make a change here, save it, run git status again, we're on branch master, but there are changes not staged for commit. If I run git diff, you can see the difference between what was from the last commit and what has been changed. In this case, hello world 2 was added. On git status again, it's still on stage, so we need to stage that by using the git add command. Git status once more to see that these are the changes to be committed. So if I run git commit, the message, save that, your code has now been committed. So if I run git status, it'll show that there's nothing to commit, but if I run git log, you can see that there are now 2 commits. in the Git repository. Git utilizes a feature called branching. Although the word branch is synonymous with a branch of a tree or subdivision of a bank, in Git, although this may not necessarily be the case, it is actually easier, in my opinion, to think of a feature branch as a clone of the codebase, but within the same project folder. For example, if you have a project which uses Git, that project will have a branch by default. Git allows you to create a new branch on that project, which essentially has the same state of the codebase as the original branch you've branched off from. Any edits you make to this new branch will not affect the original. When your edits are complete, you can then commit those edits, which at the time is only available to the branch you're on, and you then have the option to merge your commits with the original branch. The ability to branch off another branch grants numerous ways to collaborate or contribute to a project. To demonstrate feature branching, I'll use a different Git repository. This Git repository has only one file. This file has a class called FizzBuzz, but there is a problem with this class. Let's say I wanted to apply an update to this class in order to fix this problem. I'll start by running git status. I'm currently on branch master. There's nothing to commit and the working tree is clean. If I run git log, I can see that there is only one commit. In order to create a new branch, you can use the git checkout command. You'll need to apply the -b option and a branch name to indicate that you want to create a new branch, but also to check out to this new branch. I'll name this new branch fix feature. I'm currently on the fix feature branch, and you can confirm this by running git status. So if I were to apply this change, hit save, and then I'll run git status again. There are now changes not staged for this commit. So if I run git diff, you can see what the change was. In this case, the addition of these lines. Let's say I'm happy with that. I'll stage this change by using the git add command and commit it with the message add buzz. Now if I run git log, you can see that there are now two commits. The first commit, which was done in master, and the second commit, which is done in this new branch, add buzz. If I were to run git branch, there are currently two branches available on this repository. And let's say I wanted to go back to master. You can do that by using the git checkout command. And to confirm, if I run git status, I'm now on branch master. If I run git log, it still only has the first commit because the other commit that we've just created was done on the other branch. If I wanted to merge the commits from fix feature, I can do that using the merge command. So I'm currently on master, and if I use git merge, enter the branch name, and that will merge the code from the feature branch back into master. So if I were to run git status, I'm currently on master, but if I run git log, I can now see that the commits from fix feature has now been merged to master. Some of the other advantages relevant to developers are being able to see what's changed. So git track changes allowing you to see what has been changed since the last version. You can use that to quickly identify if any lines can be improved or even missing. Another feature is that you can very quickly revert any changes you may not want. For example, some developers may have used comments or logging code for debugging. Being able to see those lines and easily revert them is very useful. Or even better, you may have wanted to make a proof of concept or refactor some code, but decide against committing that code. You can easily reverse all untracked or unstaged changes back to its last commit. Another feature is the source code is easily accessible. You can push your source code to a Git hosting service like GitHub, and anyone who has access can easily download the code to their local machine. A project or source code which utilizes Git
is called a Git repository. This repository is often primarily stored on a remote server. This repository is called the remote repository. And that is where the main source code is stored and is commonly hosted by Git-based hosting providers such as GitHub, GitLab, or Bitbucket. The remote repository is what allows teams to collaborate against the same code base, to be able to download a local copy of that repository and start making contributions of their own. They can then push their commits made in their branches, or even including the master branch, back to the remote repository. Anyone who has access, such as members of your development team, can then be able to pull that code back to their local repository and thus be able to continue collaborating. Here is a flowchart of what your basic workflow will look like. I've added the Git commands you would use to achieve each step, but I wouldn't worry about memorizing those. The focus should be each step used when working in a Git repository. Starting on the master branch, make sure your local master branch is up to date with the remote master branch. Create a new branch. Start working on your feature, stage your changes, commit your changes. Are you finished? And what I mean by this is that it's a good practice to keep your commits small. Commit small and incremental changes will help you be more organized when developing software. So creating more organized commits is recommended. Once you're finished, if you have a remote repository, you can push your branch up. And often it'll go through a code review by someone in your team. Once approved, merge to the remote master branch, and you would repeat the whole process again. So this is a fairly simplified chart, but essentially this will be how you work with Git majority of the time. There may be some steps in between or other Git commands needed, depending on edge cases such as stashing code or reverting code using Git if you needed to, but otherwise this chart is pretty much Git in a nutshell. To illustrate my point, I've gathered my last 2,000 commands from my terminal to see which Git commands I use the most. It's also worth noting that I sometimes use a Git GUI when reviewing my own code changes, so staging and committing codes from that GUI is not factored in. Bear in mind that the commands in my terminal are not exclusive to Git, but this outlines some of my most commonly used Git commands. And I recommend that you learn only these at minimum to start with in order to remain focused and hopefully build a habit to help you memorize them. The reason I created this video is to make it as simple to learn a topic as possible. In my experience, when I've tried to learn something new, I find that I've spent too much time on an area and often never utilizing that knowledge. Git was a perfect example of this, and having worked with it for a while, I've noticed that the very basics were all I needed to get by as a junior. That doesn't mean there's no value in learning other useful Git features like rebase, stashing, or even undoing a commit. But because you may not use it as frequently as the others, your time would be better spent on the common commands and building habits around them. So that's it from me. Thank you for watching. I plan to create more of these kinds of videos, so you're welcome to subscribe. And if you found this video useful, please leave a like and share it. See you in the next one.